In occupied France during August 1943, on a secluded Luftwaffe airfield shortly after 4 a.m., Oberleutnant Hans Werner Schulz, chief technical officer of Jagdgeschwader 26, received what should have been exhilarating news. An American P-47 Thunderbolt had been forced down, its pilot captured, and the aircraft itself largely intact. For the Germans, this was a windfall of intelligence. For months, Luftwaffe pilots had been reporting encounters with this enormous American fighter, describing flight performance that seemed almost impossible. Now, German engineers would finally have the chance to study one up close. When Schulz first saw the P-47 sitting on the runway, his reaction was identical to that of every pilot who had faced it. It looked absurd. The aircraft's bulky fuselage and clumsy proportions made it resemble a flying milk bottle, but as the methodical engineer began his inspection, a man devoted to precision and numbers, he was about to uncover a sobering revelation. The P-47 wasn't grotesque, it was prophetic. Its engineering represented mathematical proof that Germany had already lost a technological war its leaders didn't even realize they were fighting. Schulz was not a combat pilot but an aeronautical engineer who had worked for Messerschmitt before the war. His duty was to analyze enemy aircraft, identify their weaknesses, and propose countermeasures. Upon seeing the P-47 up close, he noted its massive frame built around an enormous radial engine, the entire structure weighing nearly 8 tons when fully loaded, double the weight of Germany's premier fighter, the Focke-Wulf FW-190, which weighed about 4 tons. German pilots mockingly called the Thunderbolt the flying milk bottle, and standing before it, Schulz understood why. It seemed far too heavy to ever lift off the ground. Yet Schulz wasn't swayed by appearances. He wanted to know what it could do. When his team began their inspection, starting with the engine, the Pratt & Whitney R28000 Double Wasp, they were stunned into silence. The engine was colossal, 18 cylinders arranged in 2 rows of 9, forming a radial configuration that explained the Thunderbolt's wide nose. But its sheer size wasn't what shocked Schulz. It was the craftsmanship, the precision, the design elegance, the industrial excellence. Every part was machined with tolerances so exact that German factories could scarcely match them. The cylinders were perfectly balanced, the crankshaft a marvel of metallurgy. Schulz pulled out his notebook and began calculating. Based on its displacement and layout, he estimated that this engine produced at least 2,000 horsepower, possibly more when combined with the integrated turbo supercharger system visible within the fuselage. By contrast, Germany's own BMW 801 engine, which powered the FW-190, delivered around 1,700 horsepower at full output, a level already straining the limits of German engineering. The Americans, it seemed, were producing engines with 20 to 30% more power, and doing so on a massive industrial scale with apparent ease. As Schulz examined further, his concern deepened. He searched for signs of wartime compromises, lower quality materials, simplified parts, shortcuts driven by scarcity. He found none. The engine was built with top-grade aluminum alloys and precision bearings, every component showing meticulous craftsmanship. It was manufactured not for expediency, but for excellence. One of Schulz's mechanics, a veteran of countless German engine overhauls, pointed to the cylinder arrangement and remarked that each cylinder was individually removable, allowing quick replacement without dismantling the entire engine. Schulz nodded grimly. It was brilliant. This design philosophy prioritized easy maintenance, reduced downtime, and maximum operational readiness. By comparison, German engines required extensive disassembly for even moderate repairs. Then came the realization that truly unsettled him. The P-47's true secret wasn't just its powerful engine, it was the turbo supercharger system integrated within its design, a technological advantage that would change the very balance of air combat. Schulz had read the intelligence reports describing the P-47's power plant, but witnessing it firsthand was another matter entirely. A complex system of ducts ran from the engine, weaving through the fuselage toward a turbine mounted in the aircraft's rear. This turbo supercharger used the engine's own exhaust gases to spin a compressor at over 20,000 revolutions per minute, forcing pressurized air back into the intake and dramatically boosting power output. The engineering behind it was astonishing. The exhaust ducts had to endure intense heat without warping or cracking. The turbine needed to spin at speeds that would instantly destroy lesser bearings. Every component of the system had to be precisely tuned, because even a small misalignment could ruin the engine. German engineers had experimented with turbo supercharging before the war, but they had never managed to put such a system into operational service. The materials were too difficult to produce, the tolerances too exacting, and the manufacturing process far too complex. Yet here it was, installed in a mass-produced American fighter, not a one-off prototype or test bed, but a standard combat aircraft built by the hundreds and soon by the thousands. Running the numbers, Schultz realized the staggering implications. With this system, the P-47's engine could maintain full-rated power at altitudes where German fighters were already gasping for air. Above 25,000 feet, the FW-190 and Bf-109 both lost a significant portion of their performance because their mechanical superchargers couldn't cope with the thin atmosphere. The P-47, by contrast, would be operating at peak efficiency, fast, stable, and completely dominant at the high altitudes where the Luftwaffe had to meet Allied bombers. One of Schultz's assistants finally voiced the obvious question: can we build something like this? Schultz shook his head. Not with our current industry. This system requires precision machining, high-grade alloys, and thousands of hours of skilled labor. We're already struggling to build basic aircraft in sufficient numbers. He paused, the weight of realization pressing down on him. This level of complexity is simply beyond our capacity. The truth was brutal. The Americans hadn't merely designed a superior fighter. They had built one that represented an entire industrial civilization operating at a level Germany couldn't reach. When Schultz moved on to inspect the airframe, the picture only grew worse. The captured Thunderbolt had clearly been through heavy combat. Its fuselage was torn by cannon shells, its wings riddled with bullet holes, and yet it had not only survived, it had flown back and landed under control. Schultz traced the pattern of impacts with disbelief. Multiple 20mm cannon hits, the sort of damage that would have instantly destroyed any German fighter, had merely scarred the American one. The explanation lay in its construction. The Thunderbolt's heavy-gauge aluminum skin, strong internal framing, and redundant control systems gave it astonishing resilience. Schultz consulted Luftwaffe combat reports and saw the pattern repeated. Pilots routinely poured cannon fire into P-47s, only to watch in frustration as the big American fighters refused to go down. The reason was clear. The P-47 had been built like an armored vehicle. Where German aircraft sacrificed protection for agility, the Thunderbolt was engineered to take damage and keep flying. Its cockpit was shielded by thick armor plates protecting the pilot from nearly every angle. The windscreen was made of heavy bullet-resistant glass, far thicker than anything used on German planes, and most decisive of all, its massive radial engine served as a natural shield. Unlike the liquid-cooled inline engines used in the Bf-109 and FW-190, the P-47's radial engine had no vulnerable coolant system to puncture. Even if several cylinders were shot away, it would often keep running. Schultz found reports describing Thunderbolts returning to base with cylinders destroyed, fuel tanks holed, and control surfaces shredded, damage that would have instantly doomed a German fighter. One of his engineers muttered, "It's over-engineered. They've added weight for durability that could have been used for performance." Schultz nodded gravely. "True, but they can afford to. Their engines are powerful enough to carry the extra weight. Ours aren't. We have to chase lightness because we don't have the horsepower to overcome it." That, he realized, was the fundamental difference between the two nations' design philosophies. German aircraft were masterpieces of precision pushed to their technical limits, squeezing every ounce of performance from scarce materials. The Americans, by contrast, built with immense safety margins, compensating for inefficiency through sheer industrial might and brute power. And painfully, their method was proving far more effective. Schultz then turned his attention to the Thunderbolt's weaponry, and what he saw deepened his despair. The aircraft carried 8 Browning M2 50-caliber machine guns, 4 mounted in each wing. He quickly did the math. Each weapon carried roughly 400 rounds, for a total of 3,200. Firing together, the 8 guns unleashed more than 100 rounds per second, a storm of metal capable of shredding anything unlucky enough to be in its path. The P-47's firepower was staggering. A single 1-second burst unleashed around 100 heavy bullets into a target. A typical 2-second firing pass doubled that number to 200. In contrast, most German fighters carried only 2 or 4 machine guns, often supplemented by 1 or 2 cannons. Their total volume of fire was far lower, and their ammunition reserves much smaller. A Bf-109, for example, might carry only 60 cannon shells and about 500 machine gun rounds. Once that was spent, the pilot had no choice but to return to base. The Thunderbolt pilot, on the other hand, could maintain fire for nearly half a minute, allowing multiple long bursts across several dogfights before running dry. But it wasn't merely the quantity of bullets. The .50 caliber rounds themselves were massive, high-velocity projectiles capable of tearing through armor, control surfaces, and the structural framework of enemy aircraft. Schultz had read Luftwaffe combat reports describing the P-47's gunfire as a wall of lead. Now, examining the weaponry himself, he understood why. The 8 Browning machine guns were precisely harmonized to converge at a single focal point ahead of the aircraft. Anything caught in that cone of fire would simply be shredded. German fighters, built light for agility and with minimal armor, stood no chance under such firepower. The Thunderbolt didn't need pinpoint accuracy. It only needed to bring the target roughly into its sights and squeeze the trigger. Schultz jotted down a grim note in his report. Recommendation: avoid head-on attacks against the P-47. The probability of surviving return fire is minimal. As he compiled his findings, Schultz began to recognize a pattern that went beyond mere technical analysis. Every part of the P-47 reflected an industrial base of almost unimaginable scale. The engine demanded precision machining and rare alloys, the turbo supercharger required advanced metallurgy, the airframe consumed vast quantities of aluminum, the guns and ammunition depended on a massive coordinated production chain. Any one of these systems would have strained Germany's limited industry, yet all of them were integrated into a single mass-produced aircraft. When Schultz requested updated intelligence on U.S. production output, the numbers were almost unbelievable. Republic Aviation was already manufacturing over 500 Thunderbolts per month by late 1943, with projections of 600, 700, even 800 per month the following year. By comparison, all of Germany's fighter plants combined struggled to deliver between 300 and 400 single-engine aircraft per month, and that production was constantly disrupted by Allied bombing. Then came the most crushing realization. The R-2800 engine that powered the Thunderbolt wasn't unique to it. It was also used in several other American aircraft. Total production of that engine type alone would surpass 125,000 units during the war. By contrast, Germany's total production of all aircraft engines across every model and manufacturer barely reached 250,000, most of them far less powerful. The Americans were building more of one advanced engine than Germany could produce of all types combined. Schultz rechecked the figures, convinced there must be a mistake. But the math was sound. U.S. aircraft output for 1943 was projected to exceed 85,000 planes. German factories would manage around 25,000, a ratio of more than 3 to 1. Worse still, American aircraft were generally larger and far more complex. A single B-17 bomber required more aluminum and labor hours to build than 3 Bf-109 fighters, and yet thousands of B-17s were rolling off American assembly lines. The material imbalance was total. The United States was fighting a global war, supplying the Soviets with tanks and planes, equipping the British and still outproducing Germany in every category. When Schultz finished drafting his report for High Command in Berlin, he knew it contained dangerous truths. His analysis detailed the P-47's technical superiority and concluded that Germany lacked the industrial means to match it. His summary was blunt. The P-47 Thunderbolt represents a level of industrial and technological sophistication beyond Germany's present capabilities. Its wide deployment indicates American production capacity far exceeds prior intelligence estimates. Recommendation: tactical measures should be adopted to avoid engagement with P-47 aircraft at high altitude. Strategic assessment: continued attrition against numerically and technically superior enemy aircraft will result in unsustainable losses. In plain terms, Schultz was stating the unthinkable. Germany could not win this war if it continued to fight the same way. When he submitted the report, his commanding officer read it carefully, then looked at him with mixed admiration and concern. "You realize this won't be well received in Berlin," he warned. "Should I soften the findings?" Schultz asked quietly, already knowing the answer. "No," the officer replied. "The report is accurate, but be ready for consequences. The leadership does not take kindly to unpleasant realities." The report was duly forwarded, but Schultz never received an official response. Through informal channels, he later learned that it had been dismissed as defeatist. One staff officer reportedly scoffed. "This engineer has been demoralized by enemy propaganda. The P-47 is just crude American machinery, inferior to our designs." Schultz wasn't surprised. He had seen this reaction before. Whenever facts conflicted with ideology, the facts were ignored. For him personally, however, the inspection of the Thunderbolt had been transformative. It revealed not just the strengths of one aircraft, but the true nature of the war Germany was fighting and losing. In the following months, his predictions came true. P-47s appeared over Europe in ever-increasing numbers. Luftwaffe losses soared. Veteran pilots were shot down faster than replacements could be trained. His tactical suggestions, avoiding high-altitude combat and favoring hit-and-run attacks, were eventually adopted, but far too late. Schultz examined other captured American aircraft, and the same pattern emerged every time: superior materials, advanced systems, and evidence of a vast industrial base running at full capacity. A captured C-47 transport he studied was just one of over 10,000 produced, while Germany's entire transport fleet numbered only a few hundred aging planes. When he inspected the P-51 Mustang, he saw an aircraft that combined the Thunderbolt's range with even greater performance, powered by a Packard-built Rolls-Royce Merlin engine, one of thousands produced under American license. Each discovery reinforced the same conclusion: Germany was being crushed in an industrial war it could not possibly win. What haunted Schultz most was that this truth had always been visible. The intelligence existed. The evidence was in front of them. But the Nazi leadership refused to believe it, or worse, they believed and simply insisted that German willpower and superior spirit could compensate for material inferiority. Schultz, trained as an engineer, believed only in numbers, in physical laws, in measurable reality, and that reality was merciless. Germany was being buried beneath an avalanche of American steel. After the war, when classified production data became public, Schultz learned that even his grim estimates had been conservative. Between 1940 and 1945, the United States produced more than 300,000 aircraft, Germany about 94,000. The U.S. alone built over 15,600 P-47 Thunderbolts, more than the combined total of all Bf-109s and Fw-190s Germany had produced. Over 125,000 R-280 engines rolled off assembly lines, not only from Pratt & Whitney but also from Ford, Chevrolet, and other automotive firms converted to wartime production. This industrial mobilization was unprecedented in human history. Automobile factories became aircraft engine plants. Shipyards that once built merchant vessels now launched aircraft carriers. And the extraordinary thing was that quality never declined. American aircraft remained reliable and finely built to the very end. Germany's, on the other hand, deteriorated steadily. Material shortages led to lower-grade metals, simplified construction, and declining workmanship as skilled labor was replaced by conscripted and forced workers. Schultz survived the war and was later questioned by American intelligence officers who had discovered his 1943 report. "Did you really conclude from examining a single aircraft that Germany would lose the war?" one officer asked. Schultz paused, then replied, "I concluded that Germany could not win an industrial war against America. The P-47 was the proof. Every system on that aircraft represented a level of production and resource availability far beyond anything we possessed." The officer pressed, "But surely others realized this as well." Schultz gave a weary smile. "Many did. But in the Third Reich, telling the truth was dangerous. It was safer to stay silent than be branded a defeatist. The Americans had found his report among captured German archives. It was marked filed. No action required. "Did that surprise you?" the officer asked. Schultz gave a bitter laugh. "No, that's exactly what I expected. The Nazi leadership didn't want intelligence. They wanted affirmation. When facts contradicted ideology, the facts were discarded." The story of Werner Schultz and the captured P-47 encapsulates Germany's greater strategic failure. A skilled engineer made an honest, accurate assessment of enemy technology and foresaw the inevitable outcome, but his warning went unheeded. His experience mirrored that of others. Admiral Canaris, who warned about America's vast industrial power; Albert Speer, who knew Germany could not win a production war; Adolf Galland, who recognized the Thunderbolt's tactical superiority; and Sepp Dietrich, who understood that the Ardennes offensive would collapse for lack of fuel. Each man had seen the truth, yet all were trapped within a regime that valued ideology above reality. Their assessments were dismissed as defeatism, their caution interpreted as weakness. The Nazi state clung to the delusion that racial and cultural superiority could outweigh industrial might, that determination could defeat mathematics. They were wrong, and engineers like Schultz knew it from the moment they examined the evidence. His report should have sounded an alarm, forcing a re-evaluation of Germany's entire strategy. Instead, it was ignored and forgotten. The P-47 Thunderbolt went on to become one of the most produced and most feared fighters of the Second World War. Over 15,600 were built. They destroyed thousands of German aircraft, supported the Allied invasion of Europe, and helped secure the air supremacy that sealed Germany's fate. And it all began with one captured aircraft, and one German engineer who realized, long before his superiors, that his country had already lost a war it didn't yet understand. Not a war of soldiers or tactics, but a war of factories, fuel, and resources. A war in which the nation with more steel, more oil, more aluminum, and more machines would inevitably prevail. America possessed all of those in abundance. Germany had none.